Good afternoon, my 12th standard warriors. Welcome to the fourth session of electromagnetic induction, where we are going to discuss about what is inductor, what is inductance, and what exactly does self-inductance and mutual inductance do, and how do you find out the self-inductance and mutual inductance. All of this with me, Shreyas, your capto, your master teacher at Vedantu, going live. Hello everyone, how is everyone? Do let me know. Hello Ashley, hi Kavi, unknown Krish, Panchami, Gauri Shankar, Dayani, Panchami, Balaji, Gauri Shankar. Welcome, welcome, welcome. Welcome to this lovely session, guys. I'm Shreyas, I'm your physics master teacher, and I have been training kids for a very long time. And I'm so proud of the fact that many of my students have not just qualified for mains or just gone to a college, but in fact, they have got really amazing ranks. And many of my students, I like to proudly say this, they have got 2-digit all India ranks, and lots of students of mine are right now in BITS, NITs, IITs, triple IITs, IISERs, IISc, you name it. So I'm really hoping next year you're going to make me proud, and welcome aboard all the warriors to the special JEE English channel, which is called Enthuse. And you are right now attending the Pathfinder series, which is a long-term batch for the 12th standard students. In this Pathfinder series, I have already covered electrostatics, Gauss's law. I have also covered current, electricity, capacitors, magnetism. Right now, we are towards the end of electromagnetic induction, more one class, and then after that, you're going to have Menti quizzes, advanced sessions for the same. So, before we begin, do not forget to smash the like button. And if you're new to this channel, do not forget to hit the subscribe button out there. Good afternoon. Nice to see all of you in the afternoon. Hi Arvind, hi Navneet, hi Hari. It's very different. Hi Surya, hello Saharshia, hello Dhanush, hello AK Productions, hello Aswat. It's very different feeling. By the way, a small announcement for all of you. Tomorrow morning at 10 o'clock, you're going to have a special class, a Menti quiz. This is for open for all. For all the 11th, 12th passing out students, even your brothers, sisters, they might not be even in 11th and 12th. It's open to all. Okay, you need not be a JEE aspirant. So let's see how many of you can crack this Menti quiz. How well do you know India? And all the important information regarding the upcoming batches, be it KVPY, be it JEE batches, be it crash courses, all those things will be revealed tomorrow at 10 o'clock. It's going to be a very quick, small session. So it's not going to take up much of your time, probably half an hour tops. And let's see how many of you are going to ace it. So if you have missed any of the classes which are conducted during the week, do not forget to check out the schedule and also the playlist or our past videos on our channel. And it's a good time to also congratulate and fill this board up. It's good to flood this board up with all the ranks that we have produced. This was JEE Mains 2 result, where 1 in 2 Vedantu students had already qualified back in March in the JEE Advanced examination, and 1 in 10 students had already got more than 99 percentile. And how about JEE Mains 3rd attempt, which happened in July? Well, look at this. So many students got 100 percentile in individual subjects. 27 students got more than 99.9, and almost 700 students got more than 99 percentile from Vedantu alone. Look at this, guys. Outstanding results. Even in ICSE boards, West Bengal JEE, Kerala State Board, CBSE, so many students. Probably the screen is not going to be enough to show you all these amazing results. Yes, Nayan, I do teach in Vedantu Pro, bacha. So Ram Kailash, somebody is asking, when will Pathfinder series end? When the last chapter comes. Okay, so it's a long time, bacha, and you have long time for the JEE Mains examination. It's not going to happen very soon. Okay, so chill, you have time. Yep. So okay, so I feel jealous by seeing your results. Yes, you should feel jealous, but in fact it should give the confidence, sir, I think I can be one of them next year. And you can see the continuous improvement trends, how things are happening. It's slowly increasing. It's slowly increasing. In fact, it has been a big jump if you compare the third and the first attempt, more than 7 times the first attempt That's what we have got in the third attempt. So guys, please check out our pro subscription courses. Even I am teaching on the pro subscription courses. A lot of micro courses of mine are running even right now, and you can join them for free if you're a part of the pro subscription. I'll explain you all the 3 different packages towards the end, but most of them are same except for the last 2 points that have been mentioned. And these courses or these packages are as low as 3,000 rupees per month, which you can afford easily even via EMI option. And if you feel that you want to try it out for 1 month, go ahead, try it out for 1 month, and if you like it, continue, and if you don't like it, it's okay. Okay, chalo, let's do the next question, which is going to come up on your screen after some time. And before that, I'm going to talk about, the inductance. We are going to talk about inductors, what exactly it is. So pay attention, because there are going to be lots of questions coming up on the screen. So get ready, guys. Let's talk about, first of all, inertia. Okay, now here is the first thing. See, in mechanics you would have learnt about inertia, but that is for mass. Inertia for mass. Now what is inertia for mass? Inertia for mass means any object which has mass will tend to move as it is unless and until it is acted by an external force, like you can see over here. So this person has his own inertia. We all know that. Now this inertia tells you how difficult it is to change his state. If this guy had more mass, it would be much more difficult to stop him, or it will be very difficult to start his motion or begin his motion. So smaller the mass, easy it is to change the motion. Larger the mass, more the inertia, more is the resistance to change the state of motion. Now there is a similar property even in electricity. And what is that property called? Well, you would have guessed it, that property is called as inductance. Now how does this work? Let me explain. Okay, let's say you have a battery, okay, and it is connected to a bulb via a switch. Right now, let's say, guys, the switch is open. The switch is open. Now what you do is, at t is equal to 0, you close the switch. You close the switch. You wait for a long time, okay, and see what happens. Here is what you will see. The graph of the glow of the bulb with time is going to look something like this. It's going to start, but it's not going to glow instantly. It will take some time to reach that optimum glow or the maximum glow. Why does it take time? There is some, you can see there is some time delay for full glow, for the full glow. Now why is that glow happening after some time? Reason is, the moment you turn on the current by turning on the switch, the current would love to flow in this circuit. The current would love to flow in the circuit, but every circuit has a property called as inductance. Now what is this inductance? This inductance is nothing but inertia, but for electricity. What does that mean? That means it will resist any kind of electrical current change. So if the current was not there before, and if the moment you turn on the switch, current wants to flow, the inductance will say, hey, I'm electrical inertia. I'm not going to allow you to expand, or I'm not going to allow you to glow, or I'm not going to allow you to increase the current instantly. You'll have to wait, you'll have to change your state slowly. So electrical inertia prevents any kind of changes which happen instantly. It will resist any kind of change in the current in that circuit. Now why that comes, I'll talk about it in a bit. For now, just understand that electrical inertia prevents the rise of the current in that circuit. Once some time is over, you will see the current will saturate and it will glow fully. What would happen if the inertia was more? What if this circuit had more electrical inertia? Then it would take even longer time for the glow to accomplish completely. This red graph says it has more electrical inertia. It has more electrical inertia. Now why does it have more electrical inertia? You can see it takes a long time. It takes more time for it to achieve complete glow. And if it has more electrical inertia, that means it has more inductance. what does it have? It has more inductance. Are you getting the feeling of inductance? Are you getting feeling of inductance, guys? Is that clear, everybody? Okay, so that means every circuit will resist the change. If that is true, then why don't you see the bulbs glow slowly? Why do you see it instantly? The reason is this time delay is very small. In your usual day-to-day activities, the moment you turn on a bulb, it turns on instantly. You might get the feeling, sir, it does not have electrical inertia. The reason is the inductive property, the inductance is very, very small for most of the devices around you. So it does not take a long time for the bulb to glow or the fan to start or anything to achieve its peak capacity. So that time is usually in micro or milliseconds. So it's not felt by you so easily. Now the same thing also happens when you turn off the switch. Say for example, okay, so for example, let's say the switch, okay, the switch is already closed. The switch is already closed. If the switch is already closed, the current is flowing in the circuit. Now at t is equal to 0, you open the switch. What did you do? You opened the switch. So what will happen now? See, understand, once the switch was closed, there will be current flowing, the bulb will be glowing. So there will be glow in the circuit, and this is, let's say, the time axis. What you will see is that the glow will go down, decay slowly, and eventually it will die out. So it is decaying, and it will take some time to drop to 0. It will not instantly go away, it will take some time. Again, this is because of inertia. There was some current which was set up. The current won't die out instantly. It will take some time for the current to achieve the state of 0. So who is opposing that change? Again, inductance. What is inductance? Electrical inertia. What does it mean? Resistance to change the state of electrical current in any circuit. It resists any kind of current change in that circuit. That's what it is. Okay, Zad, welcome. Join in, bacha. You guys are a little bit late, but okay, let's start writing all these things down on the board so that it is also there in your PDF. Okay, thank you, Vengi Jarwin. All right, Panchami. So what is inductor? Inductor is nothing but like a passive. Passive means it's just there. Okay, it does not react as such. It's a component that opposes any kind of change in the circuit for current. By the way, inductors are also called as coils. Oh, any coil is an inductor. They are also called as chokes. So chokes, coils, inductors, they all mean the same thing. And what is the job of the inductor? The job of the inductor is to provide electrical inertia. It resists any kind of change in the electrical current which flows through it. And by the way, the unit of inductance is Henry. What is the unit of inductance? It is Henry. So 1 Henry will be defined in a bit, but remember that's the SI unit. More Henrys means more inertia, that means more the resistance to change any kind of current. It will oppose more if there is more Henry. This is the symbol of an inductor. This is how an inductor looks like. You just take a coil, wind it, it becomes an inductor. So if you are thinking inductor is a special device, no, it's very simple. You just take any wire and just coil it around, it will become an inductor. Now you might be wondering, how does it become an inductor? How will it oppose any kind of change? What is the logic behind the functioning of an inductor? How does it provide electrical inertia? I'll come to it. But for now, I hope you guys are getting it. Welcome, Ria, join in. You guys are probably little late, but it's okay. Okay, you can watch the replay. Probably even now, even in the live class, even if you are late, just go back, catch up at 2x speed. You will still probably arrive wherever we are in little bit of time. Now, what happens in an inductor, I'll tell you. See, the moment you take a coil and wind it, and there is current flowing through it. Okay, there is current flowing through it. The moment current flows, what does it create, guys? What does any current which is flowing in that coil create around it? It will obviously create magnetic field around it. Everybody understanding this? It will create magnetic field around it. Now this magnetic field will be passing through the coil. So let's say I create a coil, the current's magnetic field will pass through the coil. So that means it will create flux. So there will be flux through the coil, correct? There will be flux through the coil. Interesting. Now just imagine this. If somebody tries to change the current, if you try to change the current, what will happen? The magnetic field will change. If the magnetic field changes, what will happen, guys? Even the flux will change. Even the flux will change. If you try to increase current, field will increase, flux will increase. And what happens when flux changes? The moment there is any kind of change, by Faraday's law, by Faraday's and in fact Lenz's law, we know this simple fact, there will be induced EMF to oppose the change, Now don't you see why that electrical inertia has come in the first place? Think about it. Now it is obvious. The moment you try to increase the current, magnetic field increases, flux increases, Faraday's law will be like, okay, flux increased and Faraday and Lenz's both. Okay, I will create induced EMF. Direction to oppose the increase in current. So induced EMF is created. If the current is increasing, it will try to counter it by decreasing it. So it will resist the change. So there is basically that electrical, this is nothing but your electrical inertia. Okay, it's not the same as resistance. Understand, there is a difference between actual resistance and an inductor. Resistance will create some loss of energy. It will create some potential difference always whenever current flows through it. Okay, it does not resist the change of current. It resists current. Understand the difference between resistor and inductor. Resistance, this R, resists current. It opposes current. Inductor does not oppose current. If current is flowing continuously, it will not do anything. It is like a wire only. There is no difference. But if the current changes, that's when it opposes. So inductor opposes the change of current. Resistance opposes the current itself. So that's the difference. So this is electrical inertia. I hope this is clear. Do let me know, guys, if this much is understood in the chat box. Do let me know. Come on, my warriors, figure this out. Have you guys understood this logic which is written on the board? And what's the difference between a resistor and an inductor? Okay. Hi Vicky, hi Payal, hi Madhuri. Unknown, the special session at 7:30 has been shifted to tomorrow 10 o'clock. Okay, so there is going to be a Menti quiz tomorrow at 10 o'clock on Sunday on the account of Independence Day. Yashwant, yes bacha, I had my lunch. I hope you too had your lunch. Okay. Now, this property can be, mathematically written down this way. The flux which is passing through the coil because of its own current is called as the flux linkage. So what is the flux linkage? That is the flux which is linked by the current passing through the coil. So the flux created due to the current passing through the coil is called as the flux linkage, and we can clearly see the flux is directly proportional to the current. That constant of proportionality is called as L, and this L is nothing but your electrical inertia, which is inductance. Keep this in mind. This is nothing but your inductance. And from the units perspective, you can see if 1 Weber of flux is produced by 1 ampere of current, then the inductance is 1 Henry. So the inductance is 1 Henry if 1 Weber of flux is produced by 1 ampere of current. So more the L, more the flux. Check this out. More the value of L, more the flux for the same current. And more the flux, understand, Faraday's law will tell me that more EMF will be created if more flux is passing through it, because any small change in the flux, any small change in the current will create large change in the flux, and large change in the flux will create large EMF and it will resist the change even more. So large L is large inertia. I hope this is clear. Hi Saina, welcome aboard. Yes Zayed, your messages are visible. Yep. Okay, cool. Don't worry guys, all your messages are visible. Okay, cool. So this will be given to you in the notes. So flux is proportional to the current, that is called as the flux linkage, and the constant of proportionality is called as inductance. And this L will depend on the shape, the size and the materials inside it. So if there is some magnetic material inside, it will depend on that. Please do not say, sir, if current increases, L will decrease. No. If current increases, flux will increase. L is the property of this coil. Like what does capacitance depend on? It depends on whether it is parallel plate, spherical, cylindrical, and what are the distance between the plates, what is the area of the plates, all of that. So it's a property of the device. So inductance, this L is also the property of the device, that coil. How many turns are there? What's the length? All of that will decide what's the inductance. We will soon do a problem of calculating inductance as well. Okay, so let's do this. First question coming up on your screen. When a circuit has large self-inductance, then which of the following are correct? More than one option could be correct. So think about it carefully. Is the resistance to change of the current very large? Is the growth of the current slow but the decay is fast? Is the growth and decay both slow? Or the flux linked with the circuit or the devices due to its own current very large? What do you guys think? Happy afternoon, Thanga. Archana saying A, B, D. Interesting. Go. Unknown saying A, C, D. Come on, my warriors. Figure this out. B and D. Okay. So, well. Pushpendra saying D. Interesting. More than one options are correct. Let me tell you that. Okay. Well, the correct answers are actually more than one, and it is A, C, and D. I'll tell you why. See, it's clearly mentioned in the question that it has large self-inductance. That means L is large. If L is large, then the resistance to change current is large, because L is an indirect way of measuring electrical inertia. The electrical inertia is large. And if the inertia is large, what is inertia? Inertia is resistance to change the current, to change the value of the current. So don't you see the resistance to change the current will be large, will be correct. Also, we all know this formula, phi is equal to Li. If L is more, obviously the flux will also be more. So this flux will also be large. The growth and the decay of the current will both be slow because the resistance is very high. So if the current has to grow, it will take a long time, and if the current has to die out, also it will take a long time because there is more resistance. Okay, both processes will occur slowly. Okay, it will not grow instantly. It will neither allow it to grow instantly, nor will it allow it to die down instantly. It will grow slowly and it will decay also very slowly. I hope this is clear. Quite join in Bacha, and you can watch the replay of the part which you have missed even in a live class. You can move the slider, catch up at 2x speed and come to the point wherever we are. Or whatever you have missed, you can watch it later after the session ends, because the entire session will be recorded for your revision purposes. But it's always better to watch the live classes. Don't worry, Zayed. I hope you are getting it. Okay. So let's get going. Surdan, nobody knows when the admit card will be released. Whenever it is going to come, you just take it. I mean, for now, just prepare for the examination. Don't worry about when the admit card will come. They will do their job. Don't worry. Okay. Chalo. Let's go to the question where we have to actually find the inductance of a solenoid. Solenoid is nothing but number of coils turned one after the other, and the question says find the inductance. Obviously, any coil, choke or inductor means the same thing. Even solenoid is an inductor. How do you find the inductance? The logic is simple. Just try to figure out phi is equal to Li. Somehow try to get in this form. somehow try to write flux is something into current. Something into current. Okay, let's try to figure this out. First of all, see guys, the flux passing through the solenoid. The flux passing through the solenoid. Why is the flux passing? Because the current is flowing through it and it is creating magnetic field which is cutting through all the coils. Everybody gets it. Now, understand there are many coils. 1, 2, 3, 4, like that. There are how many turns? Let's say there are n turns. Don't you see the field lines cut through each coil? Cut through each coil, and every time they cut, they produce a flux. They produce a flux. So each coil, one turn, second turn, every turn over here is creating flux. So the total flux of the solenoid is capital N times the flux through any one coil. As such, everybody getting it? Now, quality, the JEE 2022 batch on YouTube has already started, and this is the 2022 batch on YouTube. But on the Vedantu platform, it is going to start on Monday. So you can check out the link which is there in the description box, and I'll be making more announcements tomorrow in the 10 a.m. session. Okay. Now, the flux through any one coil, will be given by, okay, think about it, the field into the area. Makes sense? That's how flux is defined. Flux is BA. So what is B? I don't know right now. This is the B inside the solenoid, okay, into the area. Okay, so that's the flux through any one coil. Now let's try to write down what each term would be. N is the total turns, but the given question says small n is given. Small n is turns per unit length. So in 1 meter, how many turns are there? In 1 meter, how many turns are there? That's turns per unit length. Now if the length of the solenoid is L, the total number of turns will be L into N. N turns per meter into the number of meters will give me the total number of turns. So capital N is small n into L. I hope this is understood. Everybody clear? Now, the next point. The inside magnetic field, we all know from the chapter of magnetism, is nothing but mu naught small n I. This is turns per unit length. Lastly, what's the area of the coil? It's going to be pi r square. So all the three terms I have obtained. Now we'll shuffle these terms in order to get it in this form. How? By putting the current aside and gathering all the terms apart from current on one side. Observe. So I'll have mu naught, okay, done. Then I have n square, okay, and then I also have pi, and I then also have L, and I also have r square, and the only thing left is I. Don't you see the flux in that solenoid? The flux in that solenoid is directly proportional to the current, and this entire thing is that constant of proportionality, which itself will be L. So the inductance of a solenoid is mu naught pi n square r square L. That's the answer. Everybody understanding it? Saina, I think your resolution is very low. Please change the resolution to 720p. On the right hand side, you have an option. YouTube gives you that option to change to best resolution, to optimize it to speed. Check your internet connection, check whether many people are using your internet, also check your speed, and based on that, probably YouTube would have optimized it for that speed, and that's why you're getting the low resolution. Thank you, Kwati. Yes, Narsimha, definitely. Vijay, I'm very good. Hi, Lohit. Welcome aboard. Perfecto, says Archana. Hello, everyone. Yes, let's get going to the next question if you guys have understood this question. Hello, Hari. Welcome. Okay. Chalo, let's get moving. So that's the answer. Like you got it. So now, anytime somebody asks you to find the inductance, your main aim should be to somehow show flux proportional to the current, and whatever things are apart from current, that constant will become your inductance. Keep this in mind. Okay. Now, let's differentiate that equation, and you are going to see voltage difference by Faraday's law. How? Observe this. I just now told you the flux through a solenoid is L multiplied by I. Now let's try to figure out EMF induced, the EMF induced in that coil by Faraday's law. That will be minus d phi by dt. This is your Faraday. This is your Faraday and Lenz law. Okay, Faraday and Lenz's law. Okay, cool. So using these laws, what will I get? Minus d by dt. Phi is Li. So L is a constant, so L can be shifted outside. So I'll get minus L di by dt. So this is very, very important equation. But most of the times you are interested in the magnitude of the EMF, and it will be just L di by dt. So most of the times you'll be interested in the magnitude. That will be just like spring forces kx, but some books write it as minus kx, taking into account the direction. So you hardly use minus kx, you always know the direction of the spring force 99% of the times. So you directly mark the forces and use it as kx. Same way, generally you'll use it as L di by dt unless there is a very rare case for that. So the final EMF, remember, is minus L di by dt. The minus sign just tells you that if the current tries to increase, EMF will try to oppose. If the current tries to decrease, EMF will try to help it. So it always will oppose any kind of change in the current. That's what the minus sign tells you. Yeah, you can also use del I by del t. Yes, Zayed, if it is not instantaneous and you want average values. So the average EMF will be L delta I by delta t. That's it. Okay, so the delta will specify average. All right, cool. Let's actually see this in the slides so that you have it in your notes when you download the PDF. When you join our Telegram channel, you get the PDFs as soon as possible, guys. So generally we take maximum around 1 day to upload the PDFs in your Telegram channels, and it might take some more time to upload it in the description box of any video channel. Okay, now let's solve some problems, but before that, hello Nikki, welcome aboard. Okay, and let's solve a problem, but before that, let me show you how you can replace an inductor with a battery. This is very, very useful trick for solving the problems. Many people do not know this trick. First trick, when current is constant, then the inductor behaves like a wire or a short circuit or a closed switch. Think about it. If current is constant, then what will be the value of di by dt? Come on, answer in the chat box. If I is a constant, then di by dt will be? And what will be L di by dt? Now think, if you have understood what I am hinting at, you would have understood what this statement means. If I is constant, that means di by dt is 0. Correct, Archana, correct, Janish. And if di by dt is 0, EMF induced is 0. So there is no voltage across the inductor. It's like a wire. So it behaves like a wire, nothing else, like a switch. That's it. There is nothing great about it. But the moment the current changes, the moment di by dt is there, that's when there is voltage created across the inductor. So think of the inductor as a battery whose EMF is the voltage created. So think of the inductor as a battery whose EMF is the voltage which is created across the inductor. And just instead of the inductor, show the battery. Then it looks like a simple problem with batteries and not the inductor. So if you have an inductor, replace it with a battery. But there are two cases. Now I'll explain that to you. Very good, Hari Hari. Very good, Saina. Excellent day. How do I explain this? Observe. See, in this first situation over here, I was constant. So di by dt was 0. So EMF was 0. So you can see this was like a wire. That was a logic for it. But over here, observe it carefully. If the current increases, that means di by dt, or the current decreases, in either case, di by dt is not 0, and if di by dt is not 0, that EMF magnitude wise will be L di by dt, whatever mod value you get. This EMF is the voltage created across this inductor. Voltage created across the inductor. So replace that inductor with a battery of the same EMF. So this EMF is the EMF which you get from this formula, and replace that inductor with that battery. But observe the polarities. That's very important. Why the polarities are different? Understand the logic. If the current increases, what will the inductor do? It will oppose it. So that's why the plus terminal is here and the negative terminal is here. It's opposing the growth. So here it opposes the growth. That's why it is opposite to the current. Okay, you can see that. But here the current is dying. Like it is going this way, the current is decreasing. So it will support, it will assist the current. Here it will assist the current. But remember, in both the cases it is opposing the change. It is always opposing the change. If it is trying to decrease, it will ask it to go up. If it tries to increase, then it will ask it to come down. Either ways it is opposing the change. But if you talk, in absolute terms, what is happening is whenever the current increases, it will oppose the growth, and when the current decreases, it will assist the current. It will help that current. It will not like it. My God, momos, pasta, pizza. What a name. I too like you. I like momos, I like pastas, I like pizzas. So great, we now have foods in our session. Hi Keshav, welcome aboard. Hello Kevin. Okay, cool. Is this understood, guys? Shall we do a question based on this? Observe it carefully now, coming up on your screen. Okay, remember these replacements. Constant current wire. The moment current increases or decreases, replace with the battery depending on what is happening, whether it is increasing or whether it is decreasing. Here is the question coming up on your screen. Hari, animation. Animation should be there in your head. You should try and visualize physics as much as possible. I mean, don't expect animation for everything. Remember, back in 70s, back in 80s, back in 90s, even when there are no animations, students or teachers have, understood concepts. So, understand, you should be mentally able to picturize, yes, there is an inductor, the current is growing. Okay, I should oppose it. So replace that inductor with a battery. And how will the battery be? Yes, it will oppose that change. So mentally picturize it. Don't always expect for animations. Too many animations are bad. It's injurious for health. Okay, let's see how many of you got this. So some of you have already started mentioning the answers. Excelente, guys. Beautiful. Amazing. Okay. My nickname is 𝐒𝐞𝐥𝐿. Okay, 𝐒𝐞𝐥𝐿. That's what you can call me. Okay, so when the current in a coil changes from 8 to 2 in this many seconds, the EMF induced is 2 volts. What is the self-inductance? EMF is given. Self-inductance needs to be found out. Change in current given, and time also given. So I need to use this equation magnitude wise. Okay, don't look at the absolute numbers. Okay, so EMF, how much it is? 2. L, I don't know. The change in the current, 8 to 2, that's 6. And time, that's 3 into 10 to the power minus 2. So let's cancel these things. 3 and 6, this will become 2. This 2 and this 2 will also cancel. And therefore, I will have L is equal to 10 to the power minus 2 Henry. 10 to the power minus 2 Henry is, because the answer asked is in millihenry, so I'll have to write 10 to the power minus 3 and I have to put 10 over here to maintain the equality. So this is then 10 millihenry. Hence option D is the answer. Beautiful. I can see Pushpendra, I can see Saina, I can see the unknown Dilip. Very good, Ram Kailash, excelente. Hello Dilip, welcome. Hi Kritika. Hello Suman, welcome, welcome. Is it also for JEE 2021? Yes, you can watch it, but remember these are long-term batches, okay? So syllabus will be going at a very, very, smooth pace, comfortable pace, so that a 12th standard student can understand it. And remember, this is a long-term batch. And the reason why we started this long-term batch is because a lot of students want to understand these concepts in depth and want to know how to apply these problems. concepts in problems. Okay, so for that we have started this. We could have easily conducted one short series and we could have finished the syllabus within 1 month, which many channels do, but we don't want that. Okay, so more than doing all these gimmickries, we want you guys to actually understand the concept. So that's the reason why we are taking it properly, and don't worry, the syllabus will be done well in advance. Next question coming up on your screen. Hello Pranavi, hello Sujay, hi Salman, welcome. We do not know anything about JEE 2022. For now, just concentrate on the concept. Don't worry whether JEE mains will be 4 times, 2 times, it doesn't matter. Okay, what matters to you right now is just, you know, the concept, the questions, how you are performing in the test. If some channel is telling you it will happen 4 times or 2 times without any confirmation or news, do not believe them. Okay, these are all rumors and they'll just waste your time. Instead, use that time to solve a problem. That will be better. Okay, so the current is flowing and this is a question based on derivatives. Let's see how do we do this. So the question is to figure out what is the potential difference between the ends of the coil. Okay, so if there is an inductor and if there is current, the EMF developed across the coil is given by L negative di by dt. That's pure mathematics. Okay, now let's substitute the value of the current. What is the value of the current from there? What is it? Check this out. It is A T into e to the power minus a squared t. That's what it is, correct? Now you can see a is a constant, I can move it outside. But do you see there are 2 functions here? One is t and second is this exponential function. And whenever you have product in derivatives, you use the UV rule. And how does it work? Try to remember it in case you have forgotten. It is nothing but the first function, keep it as it is, into the second function's derivative. So the derivative of e to the power minus a squared t and plus the second function, which is e to the power minus a squared t, into the derivative of the first function. That's how it looks like. U v dash plus v u dash. Now just solve this question and you will get it, guys. It's simple. So this is t. Now how do you perform this derivative? E raised to x's derivative. E raised to x's derivative is e raised to x only. It's e raised to x. But if there is some number or some value multiplied by that x, then that value comes outside. If you remember it, e raised to ax's derivative is e raised to x into a. Sin ax's derivative is cos ax into a. That constant which gets multiplied by that x comes outside. Remember that. So you will have this minus a square outside getting multiplied plus this number as it is, and we all know this is nothing but 1. Okay, so take out many things common, like e to the power minus a square t is common, and from here I can take 1 and this is nothing but minus a squared t. So that should be your answer, and which is option D, I suppose. Everybody got it? Yes, I hope this is clear. Yes, Dipanshi, some of the master classes are recorded. So you might find me in the master classes at times. So don't get scared, okay? So some of the master classes are recorded. Cool. So that's how you solve it. Beautiful question, guys. Very, very interesting, just based on derivatives. So remember, the rule which I have used over here is e raised to, kx. Derivative is e raised to kx but into k. That's the rule I have used. Okay, so that's something which you should know. You would have studied this in derivatives. Cool. Let's get going to the next question coming up on your screen. And here you have a resistance, current, battery, inductor. The current is decreasing. The question is, what do you think is the voltage difference between A and B? Come on, my warriors, figure this out. Let's see how many of you can answer this really quick. I'll put a timer over here and let's see how many of you get this really, really quick. 1 minute to solve this question. Come on, my warriors. The current is decreasing, remember, if current is decreasing, inductor will always oppose it. Replace it with a battery, simplify the circuit, it will look very, very easy. Yes, use Kirchhoff's law, correct unknown, and try to solve the question. You will get it, trust me. It's not that difficult. Come on, come on, come on, my warriors. Think, think, think. Come on. You can get it. C for Capto says Sai Telugu. Zaid also says C. Saina also says C. Beautiful. Amazing go. Pushpendra also saying C. I don't know whether it is correct or wrong. Okay, okay. Ahari also saying C. Unknown, Dipanshi, everyone saying C. Alright. So first of all, quickly, you would have replaced this inductor with a battery. But since the current is decreasing, it's mentioned, you have to help the current. So help the current by replacing the inductor like this. And the rest of the components will remain as it is. Do not change anything over there. This is point A, this is 2 ohms, this is the 2 amperes, this is 3 volts, and the current is flowing as it is till point B. Now what is this EMF? Well, just find out the value. What is L? L is given 1 millihenry. So this EMF magnitude wise is L di by dt. So L is 1 millihenry, so 10 to the power minus 3, and di by dt 1000 amperes per second, so into 1000. Well, that's simple, it's 1 V, 1 volt. So this battery is 1 volt. What is this battery doing? It is assisting the current. Why is it assisting? Because the current is decreasing, that's the reason. Now use Kirchhoff's law, A to B. So voltage at A, and then what do you get? Resistor. What will happen? Drop. So the voltage will drop by how much? I, which is 2 into R. Okay, that's first component. Second component, battery. I am going from high to low potential, so decrease, so minus 3. Then next, this battery from low to high by how much? 1 volt, so plus 1. Eventually, where do I reach? I reach at point B. So adding, subtracting all these numbers, I eventually reach point B. So this will be VA 2 to the 4, 4 minus 3, minus 10 plus 1, minus 6 is equal to VB. Rearrange and you will get VA minus VB is equal to 6 volts, and hence that is correct. All my lovely warriors were correct. Beautiful, amazing. A pat on your back. I'm proud of you. Excellent. Good. Now let's go to the next concept, and that is energy in an inductor. Yes, just minus plus, correct Zayed. Now you get a hang of it, but trust me, these kind of questions have come in JEE mains and people have messed these questions up and they got confused whether to choose the battery that way or this way. Yes, these are such easy questions. They do come in mains, NEET, BITSAT, you name it. You cannot afford to lose marks. Okay. Now, why does an inductor have energy? See, the reason is simple. Okay. Whenever you have any kind of field, that field has some potential associated with it, and the moment you talk about potential, there is some energy associated with it. And you would have seen that electric field stores electrical energy. Gravitational field has gravitational energy between two masses, electrical energy between two charges. This is magnetic field. There are no magnets, but magnetism is produced by the current carrying wire. So that's the reason why there is magnetic energy stored inside an inductor, and we all know that there is magnetic field inside this. So this magnetic field inside that inductor will store magnetic energy inside of it. It will store magnetic energy inside of it. Yes. Now, remember this formula of writing magnetic potential energy of an inductor is very, very simple. I'll give you a hint. Okay. There is a derivation mentioned on the next slide. That is for your reference. Okay. That's something which you can refer to later on after the class is over and you download the PDF. But the better part, which probably is not there in the books. That's why you come here to learn from me. And that's something which I would like to tell you. See, what is inductor? Inductor is electrical inertia, correct? Inductance is nothing but electrical inertia. Is there something equivalent of inertia in mechanics? Yes, we have the motional inertia, and that inertia of motion is mass. Everybody knows this. Everybody knows this. Mass is mechanical or motional inertia. Electrical inertia, that's inductance. Fair enough. Let me tell you, just like you have position, x refers to position, okay, and v refers to velocity in mechanics. Guess what? In electromagnetism, you have terms similar to this, and that term is none other than charge. Charge is the term equivalent to position, and I'm not saying this just for the heck of it. It's only done by comparison. People have observed, physicists have observed lot of phenomena, lot of formulas which are identical. Whatever formulas are identical in position, velocity, they are identical over here also. By comparison, they have found out this analogy. Okay. Now, what is dq by dt? dq by dt is nothing but current. So the current is the equivalent. Current is the equivalent of velocity. These are all analogies. I am not saying position is charge. I am not saying velocity is current, but it behaves mathematically in many formulas very similarly. Okay. Also, Sri Varshini, don't join the crash course for JEE 2022. You have the long-term pro subscription batches. It will be a disaster if you join right now for 2022. There will be a crash course separately later on. You don't need the entire syllabus right now in 10 days. Okay, you have a lot of time. Join the proper batch. Okay, great. Next up, see, just like you have momentum, everybody knows this momentum. Believe me, the equivalent of momentum in electromagnetism is flux. Is nothing but, what is it? Flux. I will show this to you in a very simple way. What is the formula for flux? Flux is Li, correct? What is the formula for momentum, guys? Momentum is mass into velocity. Compare them. Flux, momentum. Mass, inductance. Mass, inductance. Velocity, current. Do you see that? Beautiful. Beautiful. Sai Srinivas practiced from H.C. Verma and previous year questions of Arihan and then the Tattva module. Similarly, kinetic energy formula. What is the formula for kinetic energy? Energy possessed by a body. It is half mv square. The energy possessed by an inductor. The energy in an inductor is usually denoted by UL. That will be half. Instead of mass, what will you write? You will write L. Instead of velocity, what will you write? Current. That's it. So this is the formula, guys. I hope this makes sense. Ankit, I had given an update on our Telegram channel, and probably also it would have been scheduled on YouTube, so you should have got a notification, but it's okay. You can watch the missed part later on. Yes. Okay, understood. So this is a beautiful comparison. So flux similar to momentum, kinetic energy similar to the energy stored in an inductor. So half Li square. Keep this in mind. Let's start with a question. Okay, so the energy stored in the inductor is in the magnetic field, and I have given you the mathematical derivation, but I have also told you the derivation via comparison. The answer is the same, half Li square. Okay, let's do a question based on this, and let's see how many of you can get this within a minute. Let's see. Come on, guys, my timer is starting now. There is a choke. Choke means inductor. Okay, there is some resistance of that inductor. Okay, and it is 4 ohms. And it produces heat at 100 watts. So for us, I'm not sure why is it buffering. Just let me know if you can see me. Guys, can you see me? Can you hear me? Hello guys, can you see me? Can you hear me? Yes, okay. Now it's okay? Okay, cool. Chalo, let's solve this question then. Okay, let's solve this question. Now it's okay, I guess. Okay. See, it's mentioned in the question that when the resistance of that choke is 4 ohms, the heat is produced at 100 watts. So what is the formula for power loss in the resistor? It is I squared R, correct? So that power loss is 100, I don't know, resistance is 4. So I square is 100 by 4, which is 25. That clearly tells me the current flowing is 5 amperes. So 5 amperes of current is flowing and heat is getting lost at 100 watts. That's what the question says. The question is, while that current is flowing, what is the energy in the inductor? Now we all know the formula for energy in an inductor. The energy in an inductor is half L I square. What is L? Well, L is 10 Henry. What is I? I, we just figured it out to be 5. So this 10 by 2 is 5. 5 into 5 square. That's 125 joules. So that's the energy in that inductor. Is it clear? Understood? It looks difficult at the start. It looks crazy at the start. What is happening? There is heat also. There is inductance. At the end of the day, remember, inductor is nothing but a choke. It's just a different name. An inductor, if it has internal resistance, show it outside. Just like a battery, if it has internal resistance, you show it outside and treat it like a normal resistor. So treat this resistor like a separate resistance connected in series with the inductor. That's all you need to do. Okay, cool. Now, going ahead with the next one. But before that, some of you are asking, sir, from where do I need to solve the problems? Well, you need to solve the problems from here. This is the book. This is called as the Tattva module. Now, this Tattva module not only has, the summary of a chapter, but it also has concepts of the chapter and all the important formulas, definitions, and all the catches, the tricks, everything is mentioned. And then you have exercise 1 with easy conceptual problems to understand concept and apply the formulas properly so that you get a thorough understanding. And then you have second exercise with previous year's mains question. And then you have level 3 questions, okay, exercise 3, which are difficult questions. And towards the end, you have advanced previous year questions. So this is there for all the chapters, for all the subjects, and this will be couriered to you when you are in the pro subscription. Okay, so that's the book you should refer to, guys. Okay, now let us talk about mutual inductance. See, what was self-inductance? All this while we have been talking about it. A change in the current of a coil, opposes itself. A coil opposes its own change. That's self-inductance. But imagine a coil opposing the change in somebody else's current. Just imagine this. So imagine, there is current, flowing in one coil, and this is getting affected by another coil. That is called as mutual inductance. Think about it this way. I'll give you a much simpler example. You learn by yourself. You are probably watching my lectures, you are probably making your notes, you are studying Tattva material or whatever, you are studying your books, H.C. Verma. You are teaching yourself, although I am helping you out, but in a way it's more like self-study on YouTube. More of it. That is self-induction. But now you join a class. There is a teacher who is solving your doubts. There is a teacher who is helping you after the class. There is a teacher who is teaching you all those things, all right, from beginning till the end. There is test discussion, everything, you are getting help. So that is mutual induction. Think of it, because probably it's not self-study, it's more like, you are being helped. So somebody affecting somebody else in a way. So when you self-learn, that is more like self-inductance, and when you get taught, that is more like mutual inductance. So that's what mutual inductance is all about. And let me show that to you via a simple diagram. Observe this. Very simple, nice animation out here. And what happens, guys, is that there is current flowing here in this circuit. Look at this, there is current flowing in this circuit. Because of that current, what will happen? There is magnetic field created around it. Can you see that? Magnetic field. Now the magnetic field is not only passing through this own coil, but also passing through somebody else's coil. Now when that magnetic field passes through somebody else's coil, don't you see Faraday's law and Lenz's law, if applied, you will immediately see there should be EMF created here. So if I change the current here, the flux will change here. If the flux changes here, these field lines through the other coil will also change. And the moment there is change in flux, what will happen? EMF is created here. And that EMF is called induced EMF. And what is this coil called? Secondary coil. What is this coil called? Primary coil. This is primary coil because this is the one which is creating that change. This is called secondary coil because that is the one which is getting affected by the change. So the secondary gets affected by the changes in the primary. So this is mutual inductance. There is no contact between the two coils. I hope it makes sense. Clear, everybody? Very good, very good. So mutual inductance is defined as the property of the coils that enables it to oppose the change in the current in another coil, not its own coil. So any change in current is opposed by the current in the another coil. And with a change in the current of one coil, the flow changes too. So the current in the coil changes, the flow will change, and that creates induced EMF in the other coil. This is the other coil. This phenomena is called as mutual induction. You can see this. Very. How to remember all the formulas? Just practice a lot of problems. You cannot sit and by heart it by sticking it on your walls. That's not the correct way. Yes, you can stick it, but that's not the only way. That will not be sufficient. You have to practice hell lot of problems and you need to do a lot of revision, and only then you will get to know all the formulas by heart. And plus you should play with the formulas. You should be like, what will happen if this goes up? What will happen if this goes down? Okay. So just like before, let's talk about flux linkage. Like you can see over here, 1 second. Okay, so what is happening is one of them is primary. You can see that there is a battery connected over here. Okay, so there is a battery. So let's say this is my primary coil. That primary coil will have some current which will create some magnetic field. Now that magnetic field, some of that magnetic field will pass through the secondary coil. So the field, what field? Magnetic field. The magnetic field created by the primary, this will pass through the secondary coil. And this will create your flux linkage. This is flux linkage, but in this case it is mutual induction's flux linkage because there are two different coils. It's not self flux, it's mutual flux. Now it's very obviously seen, if I change anything in the primary, the magnetic field will also change, the magnetic field passing through the secondary will also change, the flux will also change. So any kind of change in the primary will create a change in the flux in the secondary. And we know what happens when there is a change. There is EMF which is induced by Faraday's and Lenz's law. So getting to that law, that EMF induced in the secondary will be minus d phi 2 by dt. Undoubtedly, it will be the rate of change of flux passing through the secondary coil, undoubtedly. But the interesting part is this flux passing through the secondary coil is proportional to the current in the primary coil. The flux in the secondary coil is proportional to the current in the primary coil. Why? More current, more field, more flux. So more current in the primary creates more flux, in the secondary, and that constant is called as the mutual induction constant. Okay, mutual inductance. So this M is nothing but your mutual inductance. Mutual inductance. Okay, very, very important, guys. So you should know this. It's just like phi is Li, but in the first case, flux in the same coil was proportional to the current in the same coil. Here flux in another coil is proportional to current in the first coil. So then that constant is mutual inductance. Obviously the unit will be again Henry only, it will not change. It's not going to be different. Some of you might be wondering, sir, what if I make this primary and then secondary? This is primary, that is secondary. Guys, trust me, nothing will happen. I mean, if I make phi 1 proportional to I2, I will still get phi 1 is equal to m I2. This constant will remain the same. Okay, so that's why it is called as mutual induction. Mutual. It doesn't matter whether this coil is made primary or that coil is made primary. Doesn't matter. The mutual coefficient of inductance remains the same. That's something which you should know. Okay, is that clear, everyone? Okay. So mock test is happening on Monday, Logadeep. Okay, so the mock test which happened before, probably you should have seen it. It was conducted, I don't remember, maybe on Wednesday or something. Okay, just check that out. But otherwise, the next mock test is happening on Monday. Happy Independence Day to you too, Madhuri. I'll be seeing you guys in a Menti quiz also tomorrow at 10 o'clock in the morning. So the flux through the secondary is proportional to the current in the primary. This flux is M into I, and M is the proportionality constant and also called as the mutual inductance. Okay, now what does this depend on? Again, it depends on the shape, size, how you are arranging it. Because think, if you don't arrange it properly, maybe not all the flux might not go through the secondary. So it depends on how much is the size, shape and orientations and all of that. So that's what M depends on. Same like before. Same like before. Zayed, it will be an Independence Day Menti quiz. Okay, general knowledge. Okay, so same like before. See this, EMF in the secondary, like I told you before, is d phi 2 by dt. But just now I told you guys, what is this phi 2? Just now I told you, this phi 2 is mutual inductance into I. So just take out M outside and what will you see? You will get minus M di1 by dt. So this is the formula for EMF created in the secondary coil due to the changes in the current of the primary coil. Standard formula. Remember, in self it was E is equal to minus L di by dt. If you remember it correctly, this current and this EMF were in the same coil. But here, this EMF is in the second coil, this current is in the first coil. Any current which changes in the first coil will create EMF in the second coil. That's what it tells us. Okay, cool. So let's use this formula for solving problems. So using minus M di by dt, you should be able to solve quite a few problems. Here is the next question. JSK, I have off bacha tomorrow, but I'm taking an extra class for you. Okay, so please attend. I'm coming there only to celebrate Independence Day with my warriors. That's all. Okay, Pushpendra, chutti hai mere ko, but still I'm coming only for you. So you better come and participate in the GK quiz. Some around maybe 12 questions are there. Fatafat apan karenge. Okay, cool. Let's start solving the questions coming up on your screen and let's see whether you can do this within a minute. Come on guys, starting the timer now. Figure this out. There are two coils X and Y and the question says that they are placed in a circuit such that the current changes by 4 amperes and the magnetic flux changes by 0.4 Weber. The value of the mutual inductance of the coils is Yes, thank you Zayed and thank you JSK. Okay, time is going to be up. A lot of you are saying C. I think I should end the timer quickly because a lot of you have started answering. Okay, so they are placed in a circuit there are two coils. The moment this word two coils are used, clearly this is a question on mutual inductance. And it said that the current changes by 4 ampere in coil X. That means this is primary coil. Okay, this is primary coil. And the flux changes by this much in Y. This is obviously secondary coil. Alright. Now we all know phi is equal to Mi. Therefore, del phi will be M del I. Now, what is M? I don't know. What is del phi? Yes, that's something I know. That's 0.4 Weber. And what is the change in the current? The change in the current is 4. So therefore, M will be, it will be 0.1, guys. Yeah. So where is it? It is D. Yes, option D. Some of you are saying C. I was wondering why you guys were saying D, guys. Yeah, be careful. It is, it is not C. Some of you are saying C. I was surprised why you guys were saying C. It is D. Okay, cool. Now, going to the next question. Let's see whether you can do it directly formula based. These are the kind of questions you will get, guys. Come on, let's do this. The coefficient of mutual inductance between two coils is 4 Henry. The current in the primary changes from this to this. Okay, wait. This to this. In 0. No, this 0 is not there and this in is not there. Okay, just ignore this. From 6 amperes to 1 ampere in these many seconds. Then the induced EMF in the secondary coil will be. Come on, you should be able to do this. The question is, what is the induced EMF? EMF induced is M di by dt. Just use this formula. So if you don't like di by dt, put delta I by delta t, because these changes in the current and the times are large. What is M? The M is 4. What is the change in the current? 6 to 1, that's a change of 5 magnitude. Okay, in how much time? 10 to the power minus 3. So this will become 20 into 10 to the power, yeah, I hope this is fine. Yeah, 10 to the power 3. So this will be 20 kilovolt, or I can just write it as 2 into 10 to the power 4 volts. Yep. So that is option C. This time the correct answer is C. Very good, Pradeep. Very good, Panchami. Very good, Janesh. Excellent. Very good. You can see your chance. Excellent. Good. So let's see. Yep, the answer is C. Next question coming up on your screen. To find out mutual inductance between two solenoids. Just before this, we have found out self-inductance of a solenoid. Now this is mutual inductance of a solenoid. Now here is what I'm going to do. Number of turns, length, everything is mentioned. Whatever you need for those solenoids is given. Let's take the outer solenoid, which has been labeled as probably, okay, of lengths L1, R1, R2, etc. are given. The outer solenoid, okay, 2 as the primary solenoid. This is the primary coil. And the inner one, okay, that will be my secondary. Why am I doing this? Because when I'm inside a bigger solenoid, I know what's the field inside a solenoid. Outside the solenoid, there is no formula for field, which we have learned. So it's better to stay inside a solenoid because we know the formula for the field inside the solenoid. And that's why I'm making the outer solenoid as primary. Is that clear? Everybody understanding this? Okay. Now, if the outer one is primary and the inner one is secondary, the flux in the secondary somehow has to be shown something into the current in the primary coil. Something into primary coil. That's the whole ambition, the aim of the problem. How am I going to do this? The flux in the secondary means the inner coil. The flux in that inner coil, observe this carefully, will be the flux through each coil. But it will be n times. And n is, let's say, n1 because it's the inner one. So 1, 2, 3. How many coils are there? There are n1 turns. So it will be n1 into flux through each coil. Now what is the flux through each coil, the flux through each coil will be field into area. So that field multiplied by the area of that coil. Now carefully start substituting the values. What is N1? What is N1? Think about it. N1 is the total turns, but given is small n1 and n2, which is turns per unit length. So if the length of the solenoid is L and there are small n turns per unit length, so small n into L will give me capital N. Makes sense, everyone? So can I say this N1 is turns per unit length multiplied by the length of that solenoid? So this length of the solenoid is L and this turns per unit length is small n1. So I'm just going to write this as small n1 into L. Okay, that's the first term. Similarly, what is magnetic field inside a solenoid? Oh, that's something we know. It is mu naught, but this time this will be N2. Be careful. Why N2? Because this field is because of the outer solenoid. It's because of the outer solenoid that is creating the field inside. So this magnetic field which is created is because of the outer solenoid, and that will be mu naught, that n number of turns per unit length outside, okay, into I. But this is the current in the outer solenoid. And what is the area? The area will be area of this one, because we are calculating the flux through the secondary coil. So it will be pi R2, or sorry, pi R1, pi R1 square, because the secondary is labeled as 1. So that might create some kind of confusion over here, because 1 is called secondary here, 2 is called primary. So that might confuse you for this problem, okay, but we need to solve it as per the given dimensions. Anyways, now just rearrange this. So what am I going to get? I'm going to get mu naught, okay, then I also have pi, okay, I have also n1 and n2 and L, of course, and I also have R1 square, cool, and the only thing remaining is I2. Now that is done. So flux in the secondary, the flux in the secondary is this current. What is this current? I2. I2 is the current flowing outside. Outside is primary. This is current in the primary coil. So hence this whole thing is mutual inductance. So this is something which you should remember. This is something which you should remember. By the way, try to recollect the formula for self-inductance. It was exactly similar. It was mu naught pi n square L R square. Instead of n square, you have n1, n2. Now both the formulas you can remember easily, and you can save a lot of time in the examination. So they will ask you direct questions based on this in the JEE Mains examination. So this is something which you have to memorize. So that's the answer, guys. Mu naught n1, n2 pi L R1 square. Cool. Now let's go quickly to inductors in series. Thank you, Archana Bacha. And parallel. Guys, the formulas are simple. And let me tell you, it works very similar to resistances. When inductors are in series, what will be same in all the inductors? Quickly let me know in the chat box. Come on, think about it. What will be same in all the inductors? Obviously current. The current will be same. What will be different? Different thing will be voltages. Just like in resistors. So the formula for replacing all these inductors with one single inductor is L1 plus L2 plus L3. Just like resistors. Treat them like resistors and solve it. The problem was only in capacitors, because capacitors in series behave like resistors in parallel, and capacitors in parallel behave like resistors in series. But inductors do not cheat you over there. Series is like series, parallel is like parallel. Okay, so the mutual inductance is ignored unless specified otherwise. Now what does this mean? See, each of this inductor has its own self-inductance, but the total inductance of the circuit also will be taking into account this current will affect this, this current will affect this. So there is mutual inductance between these coils. Usually you don't worry about it. So in JEE Mains, don't worry about it. But sometimes in JEE Advanced, they can ask you these kind of questions. So if you take into account how these mutual inductance are affecting each other, then it depends whether the windings are in the same direction or whether the windings are in the opposite direction. So if the windings are in the same direction, then it will be plus 2M if they are aiding each other, okay? But if they are opposing, then it will be minus 2M. So the net inductance is L1 plus L2 minus 2M or L1 plus L2 plus 2M, depending on whether they are helping or whether they are opposing each other. Keep this in mind. This is something which you should keep this in mind. Okay, but generally this 2M is ignored because these coils are very far, their mutual inductance is negligible. So that's why this last term generally is neglected for many problems. Okay, keep this in mind. Okay, so this is a very important slide for you. Similarly, for inductors in parallel, the currents will get distributed in all the branches. Each inductor will have different currents, and therefore you will see the net inductance will be just like your net resistance in parallel. So 1 by L1 plus 1 by L2 plus 1 by L3 will be the 1 by L effective. Now this is just given in many random books, so that's why I'm putting it over here, but it is not there in your syllabus. But I'm just telling it to you that if you take into account their mutual inductance, then whether the coils are in the same direction or opposite direction, based on that you will have some additional terms. So if the coils are in the same direction, you have minus m square on the top and plus 2m below, and if they are opposing each other, then you have minus m square and minus 2m both below and on the top. But generally mutual inductance between the coils are ignored, and this part is not there in the JEE Main syllabus. Okay, how do you find whether it is opposing or favoring? Just look at the diagram and look at the windings. Okay, if the windings are similar, then it is basically in the same direction. But if you see one like this and other one like this, then they are opposing each other. Okay, the windings nature will be different. That's all. Is that clear? Cool. Chalo, let's do a question based on this. Find the equivalent inductance between A and B. Come on, my warriors, figure this out. Yes. Think about it. Glad to know that, Harni Manigan. Okay, so find the equivalent inductance. Guys, if you are getting confused, I'll give you a hint. Replace these inductors with resistors and solve the problem. Replace it with resistors and solve the problem. That's it. You will get it. Very easy. Very easy. And we have done this kind of question, guys. Resistors arranged in this way, and you had wires connecting them, and had told you if this point has B potential, even this point has the same potential B, and if this point has A potential, even this point has A potential. Indirectly, all three of them are having same potential difference. All three of them have same potential difference. Actually speaking, the equivalent circuit of this is nothing but you have three inductors in parallel. Trust me on this. Each one of them has the same voltage difference. See, if this is A, this is also A. If this is B, this is also B. You can see that same voltage difference across all the three inductors. They are in parallel. So 1 by L is 1 by 3 plus 1 by 3 plus 1 by 3. So it is 3 by 3, which is 1. So L is also 1, and hence the answer is A. Done. Very good. Cool. So that's how you can solve the questions on inductance, and you can see the answer is A. So this is the first homework question, and this is your second homework question. Okay, so 2 homework questions for both of you. In fact, there is one more question if I'm not wrong. Yes, there are 3 homework questions. Yeah, 3 homework questions. Look at this. So post the answers in the chat box, in the comment section below after the video ends. And guys, if you want to really get into an institute with proper coaching, please consider Vedantu, because we are giving you that promise that you guys are going to improve. And if you do not improve, the price, whatever you pay, will be refunded back, provided you have attended all the classes and all of that. So this is VIP Vedantu Improvement Promise. And let me tell you, there are my courses also. I'm also teaching in Pro. There are a lot of amazing teachers just like me teaching over there. Okay, now all teachers cannot come on YouTube, and all YouTube teachers cannot go everywhere. So you will have a mix of teachers here and there, but trust me on this, all teachers are amazing with lots of experience. Most of them are from IITs, and all of these teachers have got amazing experience in not just coaching kids, but also producing amazing results, because that is very important. A lot of teachers are also there, but you need to have those kind of teachers who can actually give you those results, who can take up a student from a normal average level to a rankers level. There is an English batch also for you, which is starting. And let me tell you, in the long-term batch, apart from your regular coaching, you also have an option for CBSE coaching and KVPY coaching and Olympiad coaching and any other, competitive exam that you can think of. So it's like you pay for one, but you get everything, including the doubts and report cards, parent-teacher meeting, everything is there in Vedantu. If you don't believe me, try it out for 1 month, because the prices are very cheap, guys. I mean, just look at it, 3,000 rupees. When you use my discount coupon code SHHPRO, where you get 10% off. Now, what's the difference between the three? See, it's very simple. This light version has all the things that I just mentioned you. But if you want doubt solving, then you go for the classic version. This is something which most of our students take up, and this is the price you pay per month. And this is something which you can apply for via EMI. EMI option is also available. Okay. And if you want somebody to mentor you, then you go for the personal mentorship in the plus version. That's what Vedantu Pro is. It's one roof, all the courses together. Okay. So if you subscribe for 1 month, will you get the Vedantu module? The answer is no. Only if you get into EMI version or you buy the entire course, only then you'll get the Tattva module. But if you join for 1 month, you'll get the soft copy of it for that particular month, whichever chapter is going on, not for the entire year. Okay, obviously it makes sense, right? Thank you Telugu, love you too bacha. Thank you Siva, take care. Yes, Saina, yes. 𝐒𝐞𝐥𝐟 time, I'm not sure what is that, but I'm guessing something which is your custom or something. Okay, time. Okay, so see you guys tomorrow. Tomorrow 10 o'clock Independence Day quiz, Menti quiz. Do not miss that. Let's see whose GK is good, and you can get anyone. You can get your parents also. You can get your chota brothers, sisters, friends, colony friends, everyone. Get them along. It will be fun. Okay, it's not for JEE or NEET or boards or nothing. It's open for all. Let's see who the winner will be tomorrow. Okay, so take care guys. Bye bye. This was Shreyas here, and please stay safe. See you at 10. Hasta la vista.